आइए हम सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ। एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़, की आवाज़।
Celebrating Azadi Ka Amrit Mahotsav, we bring you a podcast series on STEM popularization, science, technology, engineering, mathematics and medicine, supported and catalyzed by the National Council for Science and Technology Communication, Government of India. This program is produced by Media for Community Foundation. Creative content and technical support is given by Purvasha Banerjee and Shushanto Das.
एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़, की आवाज़, की आवाज़।
Vigyan Ki Awaaz podcast series aims to popularize new ideas of science and technology, which highlight STEM, science, technology, engineering, mathematics, and medicine. This brings to the surface the efforts and researches of Indian scientists, which is desired to bring a change in community learning and teaching, access to knowledge of resources, and social paradigms. Our goal is to spread the name of indigenous Indian research stories and their masters among the masses of society in a very easy manner. Bose Institute was set up in 1917 by Sir Jagadish Chandra Bose, the founder of modern science in the Indian subcontinent. It is Asia's first modern research center devoted to interdisciplinary research and bears a century-old tradition. The institute was founded as not merely a laboratory but a temple, with its principal aims being the advancement of science and diffusion of knowledge. Swami Vivekananda, Sister Nivedita, whose influence is reflected in the institute's emblem of Vajra, was significant in the setting up of the institute, and Rabindranath Tagore were among those who had consistently inspired and supported Jagadish Chandra Bose in his endeavors. Ever since the establishment of the Department of Science and Technology, Government of India in May 1971, Bose Institute has been an autonomous grant-in-aid institution of DST. Over the last century, the institute has endlessly strived to preserve the legacy of its illustrious founder. In this podcast, we are happy to present Dr. Atin Kumar Mandal, professor in Bose Institute. Before going into details about his research work, let us hear from his own voice about his academic journey.
I, Atin Kumar Mandal, currently a professor at Bose Institute for the last 10 years. And I did my PhD from Bose Institute itself in chemistry department. Then I went abroad in Massachusetts to do my postdoctoral training. And then I moved in basically on protein chemistry. And then I moved to New York in Mount Sinai School of Medicine, where I actually learned about the yeast genetics, yeast biology, and mostly how the proteins folds inside the shells to do that. Then after came back, I utilized that, and taking from there, I started my lab and doing the current work what I'm doing right now.
Cells are working like an industry, as any industry keeps good things and throws bad things. Cells have the similar characteristics. Dr. Mandal speaks on this interesting area of research in details and also shares some of his extremely important observations.
Mostly I do, as I said, I do with work with proteins. And proteins are majorly the workforce or the building block of any living organism, from bacteria to higher eukaryotes. And one thing is that we have like more than 30,000 proteins in our body, and that works continuously to keep us alive. However, when we are alive and that these humongous numbers of proteins, those works perfectly. However, if any changes happens and cells have our body or particular cells has a surveillance mechanism, and similar to it's like a quality control machinery in industry. If you have a bad product, you just throw it out. If you have a good product, you keep it. Cell has the similar mechanisms. If you have good protein is folded perfectly, you keep them. If you do not have, it is misfolded and you trash them. So these two machinery works perfectly to keep our body alive or maintains. But if any kind of miscues like stress, environmental cues, and this disbalance actually happens. And as a result, we develop a lot of different diseases, like for example, cancers. If you have a mutation of any single proteins that called hyperactives and changes all the cellular physiology and causes abnormal growth. Same thing for neurodegenerative diseases or late onset neurodegenerative diseases, as Professor said, like Alzheimer's, Parkinson. Those are also due to the misfolding of the particular protein or couple of proteins. So what happens if you have a misfolding of the proteins? Those proteins actually accumulate in the neurons and the neuron gets damaged. And we actually lost the brain functions. And both the cases, if we can integrate both cancers and neurodegenerative disease, and we see that this surveillance mechanisms, what actually cell has, is compromised. For cancer, they work better. For neurodegenerative disease, is reduced. So we cannot keep the cell, cannot keep the balance. So I actually work in there. Mostly I worked in Huntington diseases and ataxia, where proteins has misfolded because of the lot of stretch of glutamine that actually accumulates, and you have the Huntington disease or the ataxian disease. And what we found, so actually I tried to say what mechanism actually disrupt and whether we can find which proteins might be involved to clear them, which cannot clear them. So that's why proteins gets accumulate. And we found one proteins that's actually in degradation machineries. It's called ubiquitin ligase, that the function of that protein is to tag the misfolded proteins and target to the degradation machinery. And that protein's level is reduced when we have aging. So we try to look at it in yeast, in mammalian cell cultures models, and we currently trying to do what is the mechanism, why they have reduced the levels, trying to see the mechanism, how it works, and probably in future we can do how we can use it in as a therapy, whether we can tag with any compounds and then that can recognize the misfolded proteins to facilitate their clearance. So that was my mention.
A large number of people suffers from neurodegenerative diseases. Dr. Mandal speaks about how this study shall be beneficial to those people.
Actually, neurodegenerative diseases, although right now is not is very common. If we take a statistics worldwide, and probably in 2019 we have probably 30,000, not 30,000, around, if I remember correctly, a lot of people, actually 130 millions, 55 millions of people are affected in 2019, and the projection is that 2050, 130 millions people will be affected with neurodegenerative diseases around the world, and India is not behind. The statistics says that almost 1,000 to 4,000 people in average among 1 lakh people, 100,000 people are affected with neurodegenerative diseases. And it doesn't actually discriminate any poor or rich, or whether you have any eminent person or not. Let's say Stephen Hawking, the scientist who has amyotrophic lateral sclerosis. So he lost his speech. Then Margaret Thatcher has dementia. Like Muhammad Ali has Parkinson's diseases. So it cannot discriminate. Anybody can be affected the cognitive diseases.
Dr. Mandal speaks about his collaborators and global contemporaries.
Actually, I do collaborate with Dr. Professor Anil Banbani in Bose Institute. Then I have collaboration with ISAR, Kolkata also. So doing in the fly models to pursue some works there also. Actually, throughout the world, most of the countries are working on that, because in future, as I said, there are lots of people will be affected. And the major reason is that changes in, as Professor Anirban said, changes in the gut microbiome, then changes in environment, then stress, which is not before it, we do not have that much stress. Right now we have a lot of stress, and that changes the cellular physiologies.
Dr. Atin Kumar Mandal speaks more on the involvement of Indian pharmaceutical industries.
Currently, not a lot of Indian industry actually working on to developing the drug yet, but mostly outside the US, Europe, those companies currently doing. But there are some companies, startup company actually started. That startup companies are trying to do, and if we can, right now we are trying to do in the lab, but in future, if we can get something out of it, we can definitely go to the translations.
Dr. Mandal explains some details of his research and some study on Ayurveda and many more, and also focuses on medicinal plants.
There are tremendous effect is that for Ayurvedics, we found that there are Ayurvedic compounds that not only single compounds may not be effective. Might be synergistic, but the Ayurvedic compound has probably 5,000, 6,000 compounds. But how many compounds is actually affecting, we don't know. So we are trying to analyze how many compounds are there, whether it has any effect in reduction of the disease progressions in cell, and also trying to run mouse model. And from there, whether we can reduce the number of compounds to identify probably fews, which we can mix it and can have an effect. Actually, we have the rich in medicinal plants, but we did not follow them. Probably, at least the Himalayan region has lots of medicinal plants. And currently, even the Ayush Ministry is like trying to encourage the medicinal plantations and their effect in common. So like, we know they have effects, a lot of medicinal plants, but we do not know how they are working. Currently, research is going on how specifically they are working in the cells to reduce the disease or prevent the disease progression.
We are thankful to Dr. Atin Kumar Mandal for providing us with his valuable time.